Hey guys, we're going to look at Bernoulli Trials, okay? I'll explain to you what a Bernoulli Trial is now. But for the rules for an event to be considered a Bernoulli Trial, there has to be a fixed number of trials being carried out, okay? So a trial, so tossing a coin. I can't just say I'm going to toss a coin forever. I must decide how many times I'm going to toss it. The trials can only have two possible outcomes. So tossing a coin is a prime example of Bernoulli Trial. I can either have a head or a tail, success or failure. The trials are independent. What I mean by that is, if I'm tossing a coin and if I get heads the first time, that doesn't affect my chances of getting head or tails the second time. And the probability in each trial is constant. So if it's a 50-50 chance of getting a head in my first toss, then it has to be a 50-50 chance in my second toss. The best way to explain this is taking an example. So a coin is biased, so that the probability of heads is always 2/5. Bob tosses the coin 4 times. He wants to know the probability of getting 3 heads and 1 tail. And we could use a tree diagram for that, okay, and that'd be no problem whatsoever. However, this is a Bernoulli trial because I suppose we know there's a fixed number of trials being carried out. The coin's tossed 4 times. There's 2 possible outcomes, heads or tails. The trials are independent, so it doesn't matter what I get in my first toss. I still have the same probability in my second toss. And the probability in each trial is constant. The probabilities don't change. Okay? So, here's how I'm going to do this. I am going to take my coin. Right, now I'm tossing it 4 times. I want to see how many ways I can get head. Well, I could get a head, and tails. I could also get a head, tails, and a head. And I can also get a head, a tails, a head, and a head. And lastly, I could get tails, a head, and a head. Now, first of all, let's look at the probabilities of getting a head and the tails. So a head, probability of that is 2/5, and the probability of getting a tails is 3/5. Okay, so it's just handy to know it'll help us up here. Right, so the probability of getting a head and a head and a head and a tails equals 2/5 and 2/5 and 2/5 and 3/5. That will equal 24/625. Likewise, getting a head here will be 2/5. Multiplied by another head, which is 2/5, multiplied by tails, which is 3/5, and multiplied by a head, which is 2/5 again. And that all equals, again, another 24/625. Again, we have the chance of getting a head, 2/5, the chance of getting a tails, 3/5, the chance of getting a head again is 2/5, and the chance of getting another head is 2/5. Sorry, that's head there. Okay, and that all equals 24/625. And lastly, chance of getting tails first, 3/5, and a head, 2/5, and another head, 2/5, and another head, 2/5. That all equals 24/625. In order for me to get 3 heads, I could get head, tails, this one, or head, head, tails, head, which is this one, or, notice I'm stressing the R plus, head, tails, head, head, which is this one, or tails, head, 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 which is this one. And if I add that all up, I will get 96 over 6. Okay, but there is another way of doing it. There's another formula method to do it. So let's have a look at that. Okay, so we'll get rid of all of this and see if we can derive a formula. Okay, so let's see if we can shorten these. Would I be correct in saying that this is 2 over 5 multiplied by itself 3 times? So could I just say 2 over 5 to the power of 3 multiplied by 3 over 5 to the power of 1. Okay. Likewise, this will be 2 over 5 multiplied by itself 3 times, multiplied by 3 over 5 because there's one of them. 1. Again, 2 over 5 multiplied by itself 3 times, multiplied by 2 over 5 multiplied by 1, or to the power of 1, sorry. And the last one again, 2 over 5 multiplied by itself 3 times, multiplied by 2 over 5. And now, have a look at this. This here substitutes all of this. Okay? And notice that it's the same for these. So could I write 2 over 5 multiplied by itself 3 times, multiplied by 3 over 5 multiplied by itself once, multiplied by 4. Would that actually substitute all of this? Yes, it would. Now how do I get the 4 out? Where's this 4 coming from? It's coming from, I can choose 3 heads from 4 tosses, 4 different ways. This way, this way, this way, and this way. Now think of this. Remember back to the start of probability and permutations, combinations. And we would have looked at how to choose 3 objects from a list of 4. Okay? We would have said 4, choose 3. Okay. Now that's what we're actually doing here. We have a list of 4 and we're choosing 3 from it. And how many different ways can I do that? Well, you've guessed it. 4 different ways. Okay, so that's why instead of multiplying it by 4, I can say actually what I will say is I multiply it by 4, choose 3. Do you know what answer I get for that? The exact same as what I had when I did it all out, which is 96 over 625. Okay, so let's do it from start to finish. Not using the way we did it at the start, but using just this formula. Okay. So the formula actually is, but we don't really need to know it because we'll use more common sense. The probability of our successes equals n, choose R, probability of so what we want is 3 heads and 1 tail. That's 4, I suppose 4 different events. Okay? Right, so here we go. Well, we're tossing it 4 times, and we want 3 heads. So we want to see how many different ways can we get 3 heads from 4 tosses. And that would be 4, choose 3. So how many different ways can we do it? We see it up here. It's actually 4 different ways, okay? So 4, choose 3. Multiply by, now, the probability of success is 2 over 3. And we want success 3 times. Now if we get success 3 times in that we have 3 heads, we must have 1 tail. So that would be 3 over 5, and that would be 1. Okay, now let's just have a look at how that corresponds to this. 4, R is the number of successes, and that's 3. R is the number of successes, which is 3, multiply by probability of not success, which would be a tail, and it's N, okay, which is this. Sorry, this should be an R, by the way. So we have N, which is 4, minus R, which is 3, we multiply this out, we will get 24 over last question. So, an unbiased die is tossed 5 times. Find the probability of getting 3 sixes. 6 is okay. Again, we could do it like this. Okay, could do it, and that'd be no problem. However, it'll be a lot shorter if we do it this way. So first of all, we're going to have 5, choose 3, because we're looking from how many different ways can I choose 3 things from 5 tosses. Okay? Multiply by the probability of success. Probability of success. It's a fair die, so it's 1 out of 6. And I want to get that 3 times. And if I only get success 3 times, then I must get not success. So the chances of not getting a 6 is 5 out of 6. And if I get success 3 times, well then obviously I must get not success 2 times. If we look over here, you'll see that it's n minus r. N minus r would be 5 minus 3, which is actually 2. We just throw that into our calculator. So multiply by 5 to the power of 6 squared. That is 25 over 36. If we multiply that all together, then we get 1 over 216 multiplied by let's keep going, we'll do another one. So an unbiased die is tossed 6 times. What's the probability of getting a 2 4 times? Well, how many different ways can I get a 2 4 times after tossing the dice 6 times? That will be 6 choose 4 multiply by, well, probability of success. Well, chance of getting a 2 are 1 over 6, and I want to get it 4 times. If I get it 4 times, well then obviously I'm going to not get it twice, and that will be 5 over 6. Okay, and I'm not going to work it out, I'm just going to, if you do it. Right, what about if I